Now we will discuss about dinitrogen trioxide. The chemical formula of dinitrogen trioxide is N2O3. It is also known as nitrogen trioxide or nitrogen sesquioxide. Since it has a good number of oxygen atoms, it supports combustion reaction but does not burn in the reaction. Hence, it acts as a better oxidizing agent in the combustion reaction. That is why it is used as a special purpose fuel due to its highly combustible nature. It ignites the substances like wood, paper, oil and clothes. It is also used in the manufacturing of nylons and dyes. Dinitrogen trioxide is a toxic compound. When its liquid form comes in contact with skin, it causes severe burns and injuries. These are some important points about dinitrogen trioxide. Now let's discuss about its preparation reaction. The first preparation reaction is by the reaction between the equimolar concentration of nitric oxide and nitrogen dioxide. It is a combination reaction. Let me write equimolar concentration of nitric oxide and nitrogen dioxide. Nitric oxide combines with nitrogen dioxide to produce N2O3 dinitrogen trioxide. Very simple chemical reaction. Now we move on to the second preparation reaction. In the second preparation reaction, nitric oxide is oxidized by oxygen gas to produce dinitrogen trioxide. Okay, you can see nitrogen is present in +2 oxidation state. In this case, it is present in +3 oxidation state. Oxidation reaction is taking place. Okay, we can balance this equation. Odd number of oxygen multiplied by 2. 4 nitrogen multiplied by 4. Balance oxygen. 4 oxygen plus 2 oxygen is equal to 6 oxygen. Equation is balanced. Now we move on to the third preparation reaction. We have learned about nitric acid. It is a strong oxidizing agent. Nitric acid oxidizes arsenic oxide into arsenic acid, like we have phosphoric acid H3PO4. Similarly, we have arsenic acid H3ASO4 and producing N2O3. We take water also in this chemical reaction. Now we can balance this chemical reaction. Okay, odd number of hydrogen multiplied by 2, and then we have 4 hydrogen multiplied by 2. Hydrogen is balanced. Okay, nitrogen is also balanced. Okay, 6 9 and it is 11. 4 2 is 8, 3 11. Okay, everything is balanced. If you look at it, this is a complete redox reaction. It is present in +5 oxidation state. Other side nitrogen is present in +3 oxidation state. Reduction reaction is taking place. Arsenic present in +3, 4 2 is 8, and then we have +5 oxidation state. Okay, because 3 hydrogen are there. So it is a oxidation reaction. Okay, it is a complete redox reaction. These are some certain methods to prepare dinitrogen trioxide. Now let's discuss about its properties. Next we have properties. As we have learned in the preparation reaction of dinitrogen trioxide, it is the combination of nitric oxide and nitrogen dioxide. When we talk about the structure of N2O3, it is the combination of the structure of 2 molecules. Okay, both are combined by nitrogen bond. Okay, this side we will have the structure of nitric oxide and this side we will have a structure of nitrogen dioxide. Okay, one oxygen is there, double bond oxygen is there. Okay, nitrogen valency is satisfied, oxygen valency is also satisfied. Now pay attention very carefully. This nitrogen is connected to 2 oxygen, double bond oxygen and single bond oxygen. Okay, you can see this oxygen valency is satisfied because it is forming 2 bonds, but this oxygen is forming less than 2 bond. Oxygen forming less than 2 bond will always carry negative charge. Nitrogen forming more than 3 bond will always carry positive charge. Okay, you can show the dots. Okay, now pay attention very carefully. You can see there is a conjugated system, double bond, single bond, negative charge is there. So this once if electron density comes this side, as a result this oxygen will pull the electron density. Okay, then resonating structure we got, we have double bond nitrogen, then nitrogen having positive charge, single bond negative charge, double bond oxygen. Okay, that's what we get. These are the resonating structure. You can see the bond length. Experimentally it has been found the bond length between nitrogen is quite high. It is 1.86 angstrom. That's why it can be broken easily. Hence we can say it is quite reactive. Okay, it decomposes very easily. Okay, now let me talk about another information. NO2, this is nitro group and another is also one more group that we have nitrite group, okay, ONO. In this case, nitrogen donates electron density. In this case, oxygen donates electron density. Okay, these are known as ambidentate ligands. Ambidentate ligands are the ligands which have more than one electron density, but at a time they donate only one electron density. Okay, at a time they donate only one electron density. They do not donate all the electron density. About the ligands, you will learn in coordination chemistry in details. Okay, so now this is the NO2 group. This is the NO2 group. Now in this place I can put ONO because both are interconvertible. Okay, both are almost, we can say, resonating structures. So we have double bond, nitrogen is there, then oxygen will be forming the bond. Okay, then N is there, and then oxygen is there. Okay, and we have lone pairs, lone pair, lone pair, and lone pair, lone pairs. This is the structure we have. Okay, so this is a part of ambidentate ligands. Okay, it shows ambidentate properties. Okay, so we have ONO is there, ONO, and in this case NO2. Okay, so this is nitro and this is nitrite. Okay, both structures are interconvertible, even at the presence of sunlight. At very room temperature they can convert. This form can convert into this form and it can go back. Okay, now let's discuss about its chemical reactions. Next we have chemical reactions. As we have seen in oxides, as the oxidation number increases, acidic character also increases. Higher is the oxidation number, higher is the acidic character. In dinitrogen trioxide, nitrogen is present in +3 oxidation state. That's why it is an acidic oxide. Acidic oxide. It means that this acidic oxide can easily react with bases. One more information. When dinitrogen trioxide is added to water, it forms 2 molecules of nitrous acid. Okay, since we add this molecule to water and forming 2 molecules of nitrous acid, then we can say N2O3 is also known as anhydride of nitrous acid. Anhydride of nitrous acid. Very simple chemical reaction. Okay, add 2 waters, it is forming nitrous acid. If I remove 1 water molecule, you will get dinitrogen trioxide. Okay, now since it is acidic oxide, it is also acidic in nature. They can react easily with base. Now if I add NaOH, it is base. Acid base reaction will be taking place. Whether you take base reacting with this nitrous acid, or you can take this base reacting with nitric oxide, dinitrogen trioxide. Okay, sorry, dinitrogen trioxide. So in this case you can see salt and water will be formed, displacement reaction. Na and NO2, we have sodium nitrite. OH will combine with hydrogen to form H2O. Water molecule will be formed. Okay, if you want, you can balance this equation. I can take 2 molecules and then we have 2 molecules and 2 molecules divided by 2. Otherwise, let me take sodium hydroxide with N2O3. We have N2O3 and then sodium hydroxide is there. It is also acidic in nature. Acid base reaction will be taking place. You can divide this equation by 2, then you will get simple equation. We have HNO2 NaOH. This portion will separate out, then you will get NaNO2, salt and water. That is how you can complete this reaction. Okay, now in this case also you will get salt and water because it is an acid, it is a base. Acid base reaction will be taking place. We get NaNO2 and we get water molecule. Okay, in the similar pattern you can complete the reaction. Okay, you can balance this equation. We have 2 nitrogen multiplied by 2 multiplied by 2. And so we have how many hydrogen? 1 water molecule is there. Balance oxygen. 4 oxygen, 5 oxygen. Okay, 3 answer 5 oxygen. This equation is balanced. So these are the chemical reactions of dinitrogen trioxide. In the next lecture, we will discuss about dinitrogen pentoxide.